In this topic, we shift from trust to proof. You'll see how documentation, captured evidence, decision logs, and assurance reporting make AI systems ready for audits, regulatory review, third-party assurance, and confident governance before questions arise. So far, we've covered how AI changes enterprise adoption, governance, risk, security, and compliance. Now we move from designing controls to demonstrating that they work, using credible evidence that supports audits, assurance reporting, and continuous compliance. Compliance becomes assurance only when it can be proven. A control needs an owner, a test, monitoring, and a record of results. For AI, that record goes beyond code changes. It may include data sources, model versions, prompts, approvals, exceptions, and human review. When these elements are traceable and documented, auditors can reconstruct decisions, regulators face less ambiguity, and leaders gain confidence to scale AI responsibly. Auditability is not something added at the end. It begins when the business purpose, owner, intended use, risk level, and obligations are defined. It continues through data lineage, model choices, testing results, limitations, and approvals. After deployment, the record should show human oversight, alerts, incidents, user-impacting decisions, and corrective actions. Changes, retraining, prompt updates, vendor releases, exceptions, and retirement decisions also belong in the audit trail. Evidence is useful only when teams can find it. Classify artifacts by lifecycle stage, control objective, risk domain, regulatory requirement, and accountable owner. Governance evidence proves decisions and authority. Technical evidence shows how the system was built and tested. Operational evidence demonstrates day-to-day control performance. Compliance evidence connects all of this to obligations and audits. The goal is fast retrieval. When challenged, you can show what happened, who approved it, and why it was acceptable. Audit readiness starts with a precise AI use case: who it serves, where it operates, which stakeholders it affects, and how its decisions matter. That context drives risk classification. Higher autonomy, sensitive data, safety exposure, legal or financial impact, and lower explainability all raise the tier. Once the tier is set, teams can trace it to regulations, internal policies, required controls, evidence, and approval gates. This traceability turns governance from opinion into auditable proof. Assurance is not based only on testing the final AI output. It also depends on tracing the choices that produced that output. For data, auditors need lineage, consent, sensitivity, retention, and quality evidence. For models, they need selection rationale, version, limitations, benchmarks, and use constraints. For tooling, they need configuration history across prompts, retrieval, APIs, orchestration, and guardrails. The central question is whether these choices match the approved use case, risk level, and compliance obligations. Testing evidence turns assurance from opinion into proof. Start with test plans, datasets, acceptance criteria, and control expectations. Then test performance, security, privacy, fairness, robustness, explainability, and reliability, including red teaming, adversarial tests, prompt injection, and leakage checks. Record results with clear pass, fail, exception, or conditional status. When issues appear, link them to risk treatment and remediation. Approval should happen only when evidence shows the system and its controls are operating effectively. A decision log should let someone reconstruct an outcome without guessing. Capture the basics. When it happened, what input or prompt was used, which model version responded, what it produced, and how confident it was. Add explainability evidence, such as rationale, sources, feature importance, and guardrail checks. Then record the approval path. Was it automated, AI-assisted, or reviewed by a person? Secure, searchable, privacy-aware logs turn AI decisions into auditable records. Accountability makes auditability stronger. Define who owns the business outcome: model, data, risk, compliance, and security review. Capture approvals at each gate: intake, risk tiering, data use, deployment, exceptions, and production changes. Human oversight evidence should show interventions, overrides, escalations, and rejected recommendations. As risk increases, approval gates and documentation should become more rigorous, especially for regulated or high-impact use cases. Audit readiness continues after launch. Operational evidence shows that the AI system is being watched, incidents are handled, and changes are controlled. Monitoring should capture performance, drift, bias, hallucinations, security alerts, toxicity, and policy exceptions. When something goes wrong, record severity, root cause, impact, containment, remediation, and lessons learned. Every model, prompt, data, vendor, access, or guardrail change should connect back to governance, risk registers, and continuous improvement. Evidence-first governance turns compliance into an operating pattern. As an AI use case moves through intake, risk assessment, testing, approval, deployment, monitoring, and change control, each step creates its own proof. Tickets, pipelines, registries, catalogs, security tools, and monitoring platforms can feed that proof automatically. If required evidence is missing, the workflow stops. The result is less audit scramble, fewer manual screenshots, and stronger continuous assurance. An effective AI evidence repository is more than shared storage. It connects artifacts to the system: lifecycle stage, control, regulation, risk category, owner, and audit period. Each item needs metadata, including source, date, approver, version, retention period, and evidence quality. Integrity comes from access controls, encryption, tamper detection, immutable logs, and chain of custody records. Designed this way, the repository helps teams respond quickly to audits, regulator requests, assurance reviews, and incident investigations. Audit readiness is not a document you create at the end. It is a capability you test continuously. Can you explain and reconstruct an AI decision? Can each control be traced to a regulation, risk, policy, and owner? Can evidence be produced quickly without manual cleanup? Are third-party models, SaaS features, and embedded AI included? Assurance reporting converts those answers into clear conclusions stakeholders can trust. The core lesson is simple. Auditability is designed, not assembled later. Capture lifecycle evidence, automate collection, protect decision history, and turn the results into assurance reports stakeholders can trust. Next, we move from proving compliance at a point in time to measuring continuous compliance through governance KPIs.